What's up, everybody? This is Eddie, and welcome to Create New Capacity Without a New Machine, an MSC live event designed to demonstrate how MSC and Kennametal's partnership can help you optimize that machining process. Now, with this being an interactive and engaging live stream, we not only encourage, but we anticipate each and every one of you to leave any questions or comments that you may have in our comment section on this portion of the screen. Now, remember, to take part in the fun today, you do need to be logged into your YouTube account. So, for instructions on how to log into your account or to access some of the downloadable content we'll be referring to in the stream today, I need you to click the link in the description. That'll bring you to our landing page and get you all the information that you are looking for. Also, following this demo, make sure you head on over to Kennametal and MSC's YouTube pages. I need you to hit that subscribe button, ring that bell to turn on the notifications so we can keep you in the loop with all of the amazing content we're going to be releasing. And while you're at it, we'd really appreciate it if you give us a thumbs up there and hit that like button on the video. So today we have an amazing demonstration, and we're going to be highlighting a couple of machines and some really cool tooling. We're going to start here at our Haas DS lathe. Then we're going to transition over to our Haas UMC 1000, and all of the magic happening at the spindle is going to be backed by the incredible tooling provided by our great partners over at Kennametal. So today I always have my friends with me and my partner in crime. Let's bring him on in, our good friend and our in-house CNC specialist, Aaron. Man, you ready to make some chips today?
Absolutely, we're gonna have a lot of fun today.
There we go. Hey, and as you all know, when you combine the overall MSC metalworking experience of their team, and then you combine that with the highly engineered products from the Kennametal team, you're receiving nothing less than the most up-to-date and efficient technology and tools to be able to create that capacity without adding any additional machinery. And so today, to bring even more relevancy to our viewers, we have not one, not two, but three industry leading experts from the Kennametal team here to give us the good news. So let's bring in our first expert, our good friend Chad. Chad, thank you so much for joining us. Why don't you tell us a little bit about you and what you do for Kennametal?
All right, hey guys. Hi Eddie, hey Aaron, how you guys doing? Thanks for having me today. I'm Chad. I've been with Kennametal for nearly 14 years, and I currently serve as a senior sales engineer for our machine tool industry sales team in Western Ohio.
Right on, man. Well, hey, thank you so much for joining us. I'm excited to see the demonstration that you're going to be leading us through today. And let's bring in our second specialist here from the Kennametal team, our good friend Steve. Steve, hey man, you've done this before. Thanks for joining us again. Tell us a little bit about yourself and what you do for Kennametal.
Yeah, thanks, Eddie. Good morning, Aaron. I'm Steve Archambault. I'm the North American Regional Product Manager responsible for solid carbide end mills for Kennametal. I've been here 33 years, spent a lot of time in applications, direct with the customer, tool designs, and trying to keep us ahead of the competition with the best tooling in the world.
There you go. I love it. Also excited to hear the demonstration you'll be leading us through today. And hey, last but certainly not least, let's bring in our friend Tony. Tony, thank you so much for joining us today. Tell us a little bit about yourself and what you do for Kennametal.
Hey, good morning, everyone. My name is Tony McLean. I'm a regional product manager for Kennametal as well. I oversee kind of the indexable milling portfolio. Been with Kennametal nearly 10 years. I reside in Oklahoma. So we work closely with global product managers, marketing team. We do a lot of training as well as working with people in the field as well. Some of our salespeople, even some of the MSC people, some of them I've probably worked with. So excited to be here this morning.
There you go. Hey, we are excited to have you. So, as you all know, the stage is set, the machines are ready, the spindle's hot, and the gang is all here. So, you didn't come here to listen to me talk. Let's hop it on over to Aaron. Hey, what's our first demo we're doing today?
Yeah, so like you mentioned before, we're going to start here in the DS30 lathe. We're going to showcase a couple different grades and styles of inserts here. We're going to do just some simple rough face, rough turn, and finish turn. We got two different parts here. We're going to talk about that creating capacity. We're going to program it differently using two different inserts. I'm going to go ahead and get the program started. Chad, hey, if you want to go ahead and start talking about kind of like the old school method of machining that we're going to be showcasing here.
Okay, great. Yeah, just as Aaron was talking about, what we're hoping to demonstrate here today is just showing you creating capacity without purchasing a new machine, just doing it with the machines you got on the floor. So let's just say your supervisor brings you a piece of stock and says, hey, I need you to turn this down to, say, 3.5-inch diameter, 2-inch length of cut, and you go to the tool crib and you grab just the standard general purpose Kennametal KCP25B. And right there's your parameters here. And you put it into some pretty safe running parameters at 500 surface feet, 100 thou depth of cut, and 11 thou per rev. And you're going to get the job done. For your supervisor, he's going to be happy that you got the job done, but it's going to take you a little longer than it probably should have running at these parameters.
Now, Chad, with operations like this, obviously, some of the individuals are going to be worried about the inserts and their tool life. So what do you have to say about this specific insert and its performance when it comes to tool life?
This tool is going to perform really well on tool life for you at these parameters. Again, it's very safe parameters. That's a good general purpose grade. It's the MN chip breaker that we're running in this demo here, which is just a medium negative chip breaker. You'll get good chip control out of it, and it'll run you a while.
Very solid. So obviously there are a lot of different features of this specific insert as we see it perform here in our lathe. But what's one of your favorite features or something you think really stands out with this specific tool in regards to how it can help you create that new capacity without a new machine?
Well, this tool is great for general purpose. You can run it at safe parameters. It's not really the tool that I would select for increasing capacity on your machine. We're going to get to that in the new school method here shortly on ways that you could utilize inserts that are at the same price point but get you a lot lower cut time and increase your capacity.
Yeah, that's a very, very good point. And as it continues to do work here at the spindle, do you have any specific applications where you feel this insert using some of the old school method, we might see it utilized a little bit more in the field?
Exactly how Aaron's demonstrating here. It's a great general purpose grade. If you're a shop that just does one piece, two piece pieces, and you're not overly concerned about your time, this is a great grade to use. Now, if you're getting into runs where you're doing 5, 10 plus parts, or maybe even running the same part all day, every day, you definitely want to optimize your grade selection and your cutting parameters to get the most bang for your buck out of that machine.
Solid stuff here. And then obviously we got this new school method. Are there any other specific items about the old school method, as we've kind of seen demonstrated here that we'd like to highlight?
I believe, Aaron, if you jumped over to the finishing yet, are we doing that now?
Yeah, so I just finished the rough turn. Now we're finished spacing right now. And then as soon as this space pass is done, then we're going to finish the OD of this part. Something to keep in mind with this kind of style of program, like you said, it's a general purpose grade of insert, but you're going to still get the same quality of the part, correct? It's just when we jump into this next part here with the kind of the newer school, the higher technology, we can still produce the same part, but it's that cycle time, right? It's being able to make the same part with a faster cycle time, higher metal removal rate.
Yes. Yeah, absolutely. Yeah, just to kind of highlight the metal removal rates that we're seeing here in this old school method. In the roughing, we were removing about 6.6 cubic inches a minute in the roughing process. In this finishing process here, we're removing only about an inch and a half cubic inches a minute with these parameters at 700 SFM, 30 thou depth of cut, and 6 thou per rev. In your finish here, you're gonna be producing a finish. We got some chips hanging up there. You're going to be producing a finish in your old school and your new school method that's going to be generally the same because of the finish that we're going to be applying at 6 thou per rev.
Yeah, like we said, you're going to get the same quality part. The part looks great. Finish turned out really nice. So I'm going to go ahead and load this next part in here. And Chad, if you want to go ahead and start talking about the next grade. Because like we mentioned, this higher technology, creating capacity in this machine, we're going to produce this next part much faster.
Right. And again, what you're going to be doing here is, the job and you want to optimize your tools and process for that job. This is a continuous turning application. There's no interruptions. There's no varying depth of cut. There's no casting scale. So you can really get after it. So what we would do to optimize your machine and create that capacity is to get harder grade inserts, something with higher cobalt content, and really get after that. So what we would do here is use our KCP10B on our roughing in this step here, and with KCP10B, and also getting a little more aggressive on your depth of cut, We're going to go 200,000 step to cut on the radial now, and then we're also going to increase our surface footage to 800 surface feet on the roughing, and feeding it a little bit faster at 15 thou inches per rev. So we're going to get that end cut time down significantly.
Interesting, Chad. So what we're seeing in the speeds and what we're checking out here inside the machine, is this what we should be expecting to see when it comes to chip creation, the way the coolant is flowing? Is this an ideal situation to really emulate that new school method?
Yeah, that looks great right now. Aaron's cutting a beautiful part right now. And when we get to that finish,
sorry, go ahead, Chad.
Go ahead. Yeah, I was going to say, when we get to that finish, when you talk about producing the same quality of part, what we're doing is we're going to be applying the same nose radius of 31 thou at the same feed rate of 6 thousandths per rev. So we're going to produce the same quality of part in terms of finish, but we're going to be doing it a lot faster because of the higher surface footage and the higher metal removal rate.
Interesting. And outside of kind of increasing the speed of that, are there any additional benefits to the new school method as opposed to the old school that we saw just previously demoed?
I mean, that's really what it's all about, is decreasing that cycle time and getting more capacity out of that machine. You know, in the roughing application now, or in the roughing operation now on this new school method, we're running at almost 29 cubic inches a minute of metal removal rate, which is about 5 times higher than what we were doing previously. And in our finishing application, we're running about 4.5 inches a minute now at those parameters. So it's really, that we're getting ready to jump over to the finish. It's really about just getting that part out of the machine as quickly as you can, but with a quality part.
Yeah, so something else with the creating capacity I wanted to mention, because the viewers aren't going to be able to see here at the control, but the old school method that we were running with those kind of safe parameters, I was only running at about 30 to 40% on my spindle load. And then we get into that second part with the new school method, really creating that capacity. I'm up into the 70 to 90% spindle load. So, that old school method, my machine has a lot more to give. There's way more capacity inside this machine. So that's, jumping into the newer tooling and really pushing that part where we're using up more of the machine capability, I guess, to create that capacity.
Absolutely. Yeah. You've got a machine, why not use it?
Absolutely.
Oh, precisely. And after these demos, the one question that remains is, when it comes to creating that new capacity, who needs this insert and why?
Are we jumping to the finishing? Because I was going to talk about.
We finished we finished it. Isaac, okay. Do you want to roll the B-roll of the finish? Yeah. So creating that capacity, going to that new school program. I mean, it happened in the blinking of an eye. There you go.
It did, Eddie, and I apologize. I thought we were still waiting on the finish. That all happened so much faster than the old school method. Yeah, so you really want to utilize and optimize your inserts when you're doing longer production runs, like you may have in this example, of getting the harder inserts and optimizing your cutting parameters to get that part out quick.
Yeah, when it comes to the finish here, Chad, is this what we would expect from that new school method using the insert we just saw?
Yes. Yep, and again, your finish on your old school method and your new school method, you're going to generate the same surface finish, particularly on that OD cut there, because you're running a 2 nose radius, 31 thousandths nose radius, and you're feeding it at 6 thou per rev, which those two aspects are really what control your surface finish.
Now, hey, solid demonstration, really comparing the old school, tried and true methods, but easy win and victory when it comes to really optimizing that machining process and creating the capacity with that new school method. So thank you so much, Chad, for highlighting a lot of those points. You bring a lot of expertise to the realm. So unless there's anything else, Aaron, that concludes our first demo.
Yep, I think we're ready to move on.
There we go. Hey, now we finish things up over here at our Haas DS lathe. We're going to take a second and transition to our Haas UMC 1000. But before we do, we're going to pull a couple of things up and talk about some of the digital ways that you can connect more with MSC as well as Kennametal. Now first, we're going to be bringing up some footage and talking about their interactive site. So if we can get that pulled up, as we're seeing here, this provides you an interactive catalog site with bookshelf, showing you all the applications, guideline, assembly instructions, as well as catalogs. You have the ability to select, view, you can search, and easily find some content as well as watch high quality videos. Now when it comes to NOVO, NOVO is a suite of powerful digital tools as an app, and it links together the process planning, inventory availability and purchase, as well as cost per part management and productivity improvements. You also have the ability to be able to search those part numbers and find specific tools for your particular application by filtering different aspects of the application to narrow down that selection. And then also we have the option for first choice. Now first choice in the catalogs, NOVO or online, you can find with that standard tooling. And with our standard selection of premium performance tooling covering about 80% of all machining applications, you'll have that short delivery and lead times with the highest level of service that you would expect from the Kennametal and MSC teams, providing you tools to optimize your milling, turning, and hole making applications. And then so with that, as we kind of wrap things up, don't forget we also have the Kennametal Connect where you can order 24/7. So it seems like everything is set up over there at our Haas UMC 1000. Let's turn it back to Aaron. Hey man, what do we have going on next?
Hey, so over here in the UMC 1000, we're going to showcase a couple different demos. The first tool that we're going to run here is the Harvi I TE. We're going to run a lot of different types of features on this part, and then once we're done with this milling demo, then we're going to throw in another piece of material, and we're going to showcase two different Kennametal drills, kind of getting into the creating capacity, the good, better, best options in our drills here. So I'm going to get started with this milling demo. Steve, I know we got a lot to talk about here. We're going to be showcasing a lot of things. Do you want to go ahead and start talking about this Harvi I and how people can create capacity with this tool?
Yeah, thanks, Aaron. Well, you know, I'm a true believer in a carpenter is only as good as his tools. And when you see what this tool can do, I think you'll agree. It is all about opening up capacity. So the Harvi I TE is a winner of the 2020 Edison Award because it has 4 new patents to the industry that's a game changer. You're looking at the faceted relief here. Aaron showed you the twisted end face. We have this chip gashing in the flutes that keep this tool cool and allows coolant to flow for chips. And it has some non-linear gashing in the end face that makes this thing capable of ramping at 45 degrees and plunging like a drill, which is something you need to keep in mind when you think about creating pockets or eliminating another operation with a different tool. So we're showing you a simple dynamic milling approach here. This is 725 surface footage. It's a little more than 6x2, close to 7 at 150 inches a minute, which is, great for light spindles if you have them. Really stretches tool life.
Now I know with the Harvi I TE, it does have that ball nose option. So maybe what are some of the key differences between what we're seeing here and that ball nose option?
Well, the ball nose has some real tricks in it too that are different to the industry, and it has this ripple relief behind the ball. It also has the facets in the base. Those ripples allow coolant right to the edge, and you have an extreme increase in tool life and the ability to really push that tool faster speed-wise because you're not going to create as much heat. Very versatile cutter, very successful out there. I don't know anyone who's tried it that hasn't changed over to it or really utilized it. So it's a game changer in the industry. Absolutely going to drive our competitors nuts for what this thing can do.
And you mentioned an interesting point that I kind of want to hit on a little bit more, knowing your extensive knowledge with this specific tool. Let's talk about that tool life. It's obviously something for anyone who's considering this specific item. They're going to consider that prior to making the purchase. So what do we need to know when it comes to that tool life?
Well, the tool life, some of the tricks in the design, like the chip gashing, which is patented in that flute. The way that's configured, it allows a lot more coolant to the edge, and it just changes the way that chip forms and flows. And anytime you can keep that tool cooler, it's going to last wear is in fact friction and heat. So now we did a little more aggressive cut here at a 60% step over at 600 surface footage, 2.5 per tooth. It just buzzes along. Here is a trochoidal arc. That's a very popular approach today, and that is one way to utilize that equipment you have. That's also a tool life stretcher there. Almost all of software programs today have dynamic or volume mill built in. It's a great approach. You use it a full length of the cutter rather than just the end, so you're stretching the use of that edge, which makes it last that much longer. So tool life is key with this particular cutter. It's part of its design enhancement.
No, it sounds like it. It looks like we have our good friend Mike Taylor. Mike, thank you for joining us today. He's got a question for you. Steve, he says, what diameters do these come in? Can you give us a little bit of insight here?
Yeah, this has a great range, greater than most you'll see in the industry. It starts at 1/8 and goes all the way up to 1¼ inch. There aren't a whole lot of manufacturers that offer 1¼ inch diameters standard on the shelf. It has an extreme range of radius offering too. All the standard aircraft radiuses, that 1¼ inch is very popular for me in some of my larger aerospace accounts. So it's a great range. It's the same in metric. Not quite as large a diameter on the top end, but 1/8 inch and 1/4. That's you won't see that range in many end mill offerings. Good question.
Now, Steve, kind of getting back to the creating capacity conversation. So I know, there's the Go Mill, there's the original Harvi. That's something that I'm used to using here in our shop, and then upgrading to even the Harvi I TE. Can you kind of explain a little bit on kind of what that step up and how each new tool is essentially creating more of that capacity?
Well, the capacity is being able to do things more aggressively. The Harvi I is a great tool, and I highly recommend that. But here's a good demo and a good example of that. That's a full diameter depth, which you could do with the Harvi. But when you start getting into 3/4 deep, like you're seeing in this cut here, most tools won't do that comfortably. You hear how quiet this thing is in the cut. That's opening capacity. Be able to take that heavier, faster cut and really utilizing the horsepower in that machine. You can push this thing to its horsepower max. Now here's something as far as capacity. This is a 45-degree ramp. And those of you in machine, you probably have not seen that happen. This will do this in a blind pocket, by the way, in a full slot. We did this for the purpose of showing you that capability. But keep in mind now, when you see that, because this thing can do that or plunge like a drill, you might eliminate a complete operation and a tool change by taking out a high feed mill to create that pocket or drilling to create that entry. You can use this end mill and totally eliminate that operation. And obviously, at any time you do that, you're going to open up capacity.
Well, the question stands that we've been able to see a lot of variety and versatility with this specific option. Who needs this tool, and why would it help them create that capacity we keep referring to?
Well, number one, this tool will work in anything. It doesn't matter if it's 1018, alloy steel, stainless steel, titanium, Inconel. It's a go-to tool that outperforms anything out there. It really is a game changer. The tricks in this cutter just allow you to be a lot more aggressive in your feeds, your speeds, your depths of cut, the approaches with the plunging. If you ever plunge with an end mill, you got to back off. You drill with this tool. So that's eliminating a process. You can do those ramps. So you can ramp into the bottom of your pocket and create it. So it's a go-to tool. If you're stocking tools for variety of materials, you only need to stock one, and it's this one. And it really is going to make a difference in utilizing that machine and maxing out the capability. I mean, there's no sense in spending 6-7 figures on a machine and looking for generic, general purpose end mills. You need to put the right tools in there and push them. And that's where your capacity comes in.
Well, I think we can all agree that we definitely pushed this tool and created this block alone is a really good testimony to the type of work and the versatility of that specific tool. And one last question that we had and we had known and kind of existed here is, you talk a little bit about the cost per part versus the cost per tool. Can you hit on that a little bit?
Yeah, I mean, it all comes down to cost per part. When you look at analysis in the tool industry, Your tooling cost is like basically 3%, the actual tool cost. The rest of it is in time, in labor, and all the rest. So if you're thinking about buying an end mill and you're worried about an extra $10 to go to something generic, some general purpose, you're hurting yourself, because that tool will not get you to that cost per part. You need to take the highest performance cutter you can put in there. In the end, the tool's going to be cheaper because it's going to last longer, and it's certainly going to create a part faster. So it's not about that upfront cost, and we will document cost savings. MSC metalworking specialists are some of the best in the industry, coupled with our people from Kennametal who do this every day. We will look at that cost per part, and we will prove to you it isn't in the cost of the tool. It's in the time on that machine.
Now, Steve, something else that I wanted to show here, I think Isaac's going to pull it up. You know, we saw that 45-degree ramp, which was awesome. But you were nice enough to send us this video clip of this S-full radial slot here that Isaac's going to pull up here. There you're seeing it. Can you kind of explain what's going on here?
Yeah, this is a full 5-axis, turn. This is you can see it for yourself. It's not only S-curving through that part, it is Z-axis milling up and down, ramping as well. And I don't know if you'll ever find a tool to go that deep, that aggressive. This is 550 surface footage at 2 per tooth, and I believe that's twice the diameter in depth. That's a full 1-inch depth.
That's a 1-inch depth.
And show me another tool that'll do that. That's 5-axis, ramping, turning, twisting. There isn't a tool in the world that'll match that. You will bind and break with anything else you try this with. And it's all got to do with those tricks, those patterns, the faceted relief, the twisted end face. I almost dropped when I saw that first demo. I just didn't think that was possible.
I mean, I was impressed with what we had done just with this block. I didn't know we're changing angles and getting other axes involved. That's nothing short of impressive. So just the continued highly engineered products from the Kennametal team. So with that being said, we thank you so much for your insight. Steve, is there anything that we're doing with that second demo? We're moving on.
No, we're moving on. I think we're good to go.
Right on, right. Well, what's next on the docket for us, Aaron?
Yeah, so next I mentioned before, we're going to get into some drilling. So I went ahead and changed out parts here. So the first part that we're going to run here, we're going to showcase kind of the good and better options here. And we'll bring in Tony here. The first tool I'm going to run is just going to be a 1/2-inch high-speed steel drill. And then we're going to get into the Kennametal GOdrill. So I'm going to go ahead and get this thing rolling. Tony, if you want to go ahead and take it away and kind of just explain how this good, better, best option and how customers can create that capacity with this new technology that's coming out here.
Oh, absolutely, Aaron. When we think about the machine tool sitting in the shop floor, and it's a static. I mean, it's a piece of equipment there. I mean, it's a huge investment. So we got to look at what we're going to utilize on the machine to actually increase that capacity. As Steve was saying, a carpenter's only as good as his tools. You could dig a ditch with a shovel, or you could dig it with a backhoe. So it's the better the tool. So, high-speed steel drills, it's something everybody has. I mean, it's been a staple for many, many years in shops, and kind of a go-to thing. They go grab it. Excuse me. They can grind it themselves, which also can create issues unless you have extra equipment that you use for grinding the drill point. There's not a lot of technology in the drill at all. Again, they've been around forever. So takes a lot more thrust to push these high-speed steel drills through materials, but you can run them in a lot of different materials as well.
And as we ask for the other types of drills, what type of tool life are we looking for this specific tool?
Well, a high-speed steel drill, not the best tool life, that's for certain. It'll fluctuate depending on the type of material you have. I mean, you can see there the chip stringing up on a drill and slinging off. I mean, that's another issue that you have with this older, with high-speed steel drills, is it's not very good for chip control. So it can cause a lot of different issues. Heat gets in there. So the tool life typically, again, varies on the different types of materials you may drill with it, but typically not a really good tool life by no means.
Now, one thing I noticed, Tony, when we were running these kind of in that testing phase here, was the the quality of the hole, and not only the quality, but the tolerance of the hole. You know, when you get into a high-speed tool, you kind of lose that quality and that ability to hold a tolerance with that kind of tool.
Oh, absolutely. I mean, we think of a drill making a round hole, but when you really get down and use the equipment to measure the diameter and the roundness of the hole, they're not always round. So, you know, again, that would depend on the specifications of the part that you're machining. But you can see here as we move to the GOdrill, you know, we're getting great chip control. It's got a marginless design, so it helps reduce friction and the heat, which actually increases tool life. So we can see here we got much better chip management with this one, with this particular GOdrill, running it quite a bit faster, 300 surface footage, 11 thousandths per rev.
It looks good and it's doing work. And hey, remember everybody joining us today, make sure you pop in that chat box for any general questions or comments that you may have. Never know, maybe able to pull those up and answer your questions in real time. And as we wait for the next questions to come up, Tony, I have one for us. So really, why would somebody mainly want to upgrade from that high-speed steel tool to the GOdrill? What are some of those major advantages that you think really stick out and separate this drill from the previous one?
Oh, great question, Eddie. You know, the GOdrill is a general purpose drill. It starts out at roughly 39 thousandths in diameter and goes up to nearly 800 thousandths in diameter. It is a solid carbide drill, so it's economical. It's our economical line. So you could have these, you know, sitting around in your shop as well over a high-speed steel drill. You know, it does have some technology in this particular drill. The TIN coating that you see there helps provide longer tool life. So there is some advantages. These drills, as you can watch this one drill much faster than the high-speed steel drill, definitely pays for itself. You know, the return on the investment's pretty quick.
It seems like it. And we have Michelle Christine. Michelle, thank you so much for joining us on the stream and for leaving a question. So the question is, what material is the GOdrill recommended for? Tony, can you give us a little bit of gospel on it, sir?
Yes, the GOdrill is a general purpose drill, so you can run it in all materials, alloy steels, you can run it in high temp alloys. So it's a general purpose, so you could run it, it's not material specific, so you could run it pretty much in any type of material that may come across your machine.
No, very good. And then as we kind of continue to run through this GOdrill, obviously, Tony, you know so many features with this, but do you have any specifically that you would deem your favorite that really helped this one stand out in the market?
Yeah, I mean, you know, number one, I think it's the very economical cost on it. You know, people would be surprised when they actually start purchasing some of these drills, and you can equip your business with them as well, and you can see you can drill so much faster. But you know, there is some true benefits, the flexibility. I mean, from 39 thousandths in diameter to 787 thousandths in diameter, with about every 20 thousandths in between. So you can pretty much fit any hole diameter size that your part that you're machining may be calling out for. So you have that. You know, it is a general purpose, so you can run it just like a high-speed steel drill. You can run it in several different types of materials. It's not material specific, so it gives you that flexibility as well. So it gives you some options with this drill.
There we go. We have another question. Ed, thank you so much. Hey, I like your name, buddy. That's awesome. Hey, with that, his question is, what type of holders do you recommend for these type of tools? What do you have for us, Tony?
Well, you know, as a tooling guy, I'm always going to recommend the best. So I said, you know, high-speed steels are running Morse tapers. You know, sometimes we just run them in a regular type of chuck. Sometimes even grind a flat on them and stick them in an end mill chuck. I prefer our Hydroforce holders. To me, that's a very precise holder when you're running solid carbide drills, especially as we move to the next drill and start discussing briefly about the HPX drill. So I prefer the Hydroforce holder, but you can run it in our HP line, a hydraulic holder, at a milling chuck. You can run them in milling chucks, heavy-duty milling chucks. Eddie, you can run them in ER collets for that matter. But, you know, it's all about, especially when you get into high-performance tools, using high-performance holders and getting the best tool life and the best precision hole diameter that you can get.
No, very good. Hey, and we have another question. Mike, thank you for joining us. Thanks for leaving your question. Mike's question is, do these GOdrills come in through spindle coolant, and what coatings are available?
Yeah, well, the coating is actually a KC7525 is the actual coating that's on the drill. So it's same on all the drills. We don't change it up on the GOdrill. And they come in 3 times, 5 times, and 8 times D. So, the different lengths as well.
Yeah, very good
And
question.
coolant, I'm sorry, you had a question there
Go ahead,
also.
please, Tony.
Yeah, the coolant through and non-coolant through. So you can get both. The smaller diameter, of course, you don't have coolant through, but you can get, typically on the mid-sized drills, you can get coolant or non-coolant through drills.
Solid answer. So as we get a quick close-up here, we're going to check out some of the finishes that we can see here on this part. So knowing kind of what we've started, is this the top line here with the first drill? What are we looking at?
Yep, so that first top line is your high-speed drill, and then all the other holes that we put in there are the GOdrill. And then I just loaded up a second part here, and we are going to showcase here the HPX Drill.
And then prior to, Patrick, keep up these questions. Thank you so much, Patrick, for joining us and for your question. His question, Tony, is what length to diameter ratio is the GOdrill platform offered?
Yeah, they're actually offered in 3 times diameter, 5 times diameter, and 8 times diameter.
Good deal. So I think we're ready to get this second drill going here. We're going to run the HPX drill. Tony, I know we gave you kind of limited amount of time to talk about this drill here. It's going to be running pretty quick, so I'm going to go ahead and start the program here. If you want to go ahead and start talking about this next drill that we're creating capacity with in our machine here.
Yeah, absolutely. The HPX drill is a material specific, so it's not a general purpose. So it is material specific to alloy steel, and you can see here. We want to watch this because it'll go through these holes pretty quick. It is a patented drill point design, which actually provides excellent self-centering capabilities, and it actually reduces the thrust. So, modern technology actually have patents. Like Steve had mentioned on the Harvi I TE had 5 patents. I mean, we're still putting patents, and we got a patent on a drill. So it does provide excellent self-centering capabilities, and again reduces the thrust. One thing we didn't talk about, a lot of times when you run a high-speed steel drill, you have to use a center drill. Well, with these precision drill points, the GOdrill and the HPX drill, typically, unless you get into some really length to diameter ratio, you don't need to use a center drill or a spot drill, so you eliminate that additional tool. But you can see we're moving through this pretty quick, 850 surface footage, 16 thou per rev, almost 104 inches per minute. So, and again, low thrust, because of the drill point design, so it's easier on your machine, and it really doesn't take the power to push it through there like you think it would.
So when it comes to this specific drill, how does the HPX compare versus other solid carbide drills in the market?
Well, I mean, again, it is a very high precision. It is a patented design, so it's material specific. So at Kennametal, we have some very high precision tools that we make more material specific versus general. So in alloy steel, which is what we're running here, whether it's your just your soft steel, your tool steel, pH stainless steels even, you could run this drill in. So it gives you that flexibility across the spectrum of steel product. So, to me, it outperforms pretty much any other drill out there on the market. As you can see, we're getting through these holes really quick, and the precision of the hole, the diameter of the hole, and the roundness of the hole, going to be very precise.
Yeah, it's absolutely sprinting through this operation. And hey, we got Larry coming and join us. Thanks, Larry, for your question and for joining us on the stream today. Larry wants to know, what hole diameter tolerances can you hold?
Well, I mean, that's a great question, and that's always a concern, especially if you're going to use a drilled hole for a finished diameter. I mean, just like anything else, cutting tools have a tolerance on them as well. But most of the time, I would say this tool is usually within about 1/1000th of the diameter of the drill itself.
Very solid, very solid. So with that, are we done with that drill already?
Absolutely, yeah. I told it was going to run quick. Tony did a good job getting everything out there while it was running. But Isaac, if you want to cut to the phone here, I got the kind of the finished quality of the hole, and even going kind of speaking to that tolerance question there. I was able to take a gauge pin, a 1/2-inch gauge pin, and slide it right through these holes. Hardly any play whatsoever. The 501 pin actually did not go in. So I mean, this particular hole was able to, or this particular drill, I'm sorry, was able to hold a pretty good tolerance.
And typically they do. Typically they do hold a real close tolerance on it. So in some cases, if you were going to ream that hole, I mean, you'd have to measure the finish of it, but sometimes you can eliminate other processes by using, something such as the HPX drill. But I do just want to speak briefly again, Hydroforce holders, precision tool, precision holders, but you could use the HP holder all the way down to any arc holder if that's what you had in your shop to utilize these type of tools.
Mm-hmm. Well, the final question we have is, we've seen the versatility, very dynamic tool. It seems just clearly just a side-by-side comparison says everything we need to, but who needs this tool and why?
Well, the good, better, best, we've seen the numbers there. I mean, we took high-speed steel, half-inch, 63 holes, took, 26 minutes roughly, almost 30 minutes. The GOdrill, of course, we eliminated that down to 5 minutes and 15 seconds. And then the HPX drill, you can see there's down to just barely over 2 minutes. So when we think about increasing capacity, if you're drilling holes, and it's something that's sometimes overlooked. I mean, if it's a onesie, twosie type, people just go grab a high-speed steel. But even at that, if you look at 26 minutes to 5:15 versus the general drill of the GOdrill, all the way down to 2 minutes 14 seconds. I mean, time's money, as we discussed. So freeing up that capacity, getting more parts across your machine, that's what it's all about. So everybody, if you're drilling holes, you need this drill.
I like it. If you're drilling holes, you need this drill. So hey, aside from that, before we finalize our last demo here, we got our man Patrick. So is the patented point recommended for inclined entry applications? What do you have for us, Tony?
If we were doing, a short, probably the 3x-D, you could get by with it. But if it's going to go any longer, then I would definitely recommend a spot drill.
Yes, very, very good questions. And thank you so much for your insight. Was there anything else you had to add, Tony?
No, that's pretty much it. I mean, the return on your investment on this drill, we also have a reconditioning program for the drill as well. So that way you can get it back to manufactured specifications from us.
Oh, and we have a comment here from MSC Direct. So for the price, it's the best drill on the market. I have drilled 55 HRC with this. So for our viewers in there, I even put like myself who may not be familiar with HRC. Are you familiar with HRC?
Yeah, so they're talking about the hardness of the material. Tony, if you want to speak a little bit more on what that comment was really saying.
Yeah, I mean, when we think about alloy steels and we think about softer type materials and we think about that Rockwell hardness, and then he's running 55 and drilling holes in it and loving it. That's pretty hard. That's, as we know in the machining world, that's pretty hard material. So that's excellent. I'm glad he stuck that up there and shared that with us.
Yeah, great comment. Aaron, hey, thanks for having my back on that one. I don't know what I'd do without you, man. So, and then Tony, great insight. So, ladies and gentlemen, that really concludes our demos today. Really brought in those experts to provide an infinite more value. And before we end things and put a pretty red bow on this conversation, we're going to bring each of our experts in one more time for any final thoughts. So first off, let's bring in Chad. And Chad, the question is, how can we use the tools that we've seen today to create the capacity without a new machine? What do you have for us, man?
Well, I'll speak to even more than just the tools that we've watched today. Is the software that you showed in between moving from machine A to machine B. Download NOVO. I'd recommend that for everybody out there. It's a great tool to utilize to know what the benefits are and what the capabilities are of the tools that you're selecting, and it'll help you select the right tools for that job as well.
Yeah, very good, very good. Well, again, thank you so much for joining us. We appreciate your expertise. Next, let's bring on Steve. Steve, hey, same question, man. Give us the gospel.
Well, as I said, the carpenter is only as good as his tools. And, like probably a lot of these guys out there, they're do-it-yourselfers. I'm a guy who restores cars. And, it used to be in the old days, old school, I probably find a 20 millimeter nut I didn't have a wrench for. I'd bang my knuckles with channel locks and pliers and finally break down, go to AutoZone and get myself a 20 millimeter socket. And guess what? 2 minutes later, it's done. And I could have sat by the pool with a beer. I could have done the brakes, whatever. It's really about buying the right tools. There is no sense having a 6 or 7 figure machine and putting generic cutters in there. You need to utilize it. You need to max out the spindles. Aaron made a good point in the beginning on the turning where he went from 30% but pushed that machine to 70%. That's what they're built to do. You can't do that with just any tool. You need to find the right tool. You need to make that investment up front, because in the end, it is going to cost you a lot less. And like I say, the people at MSC are very good at documenting that. Kennametal spends its life testing against competitors to document and prove that fact to you. So you got to get the right tools, and that Harvi I TE is a game changer for you.
I love your expertise, I love your passion, and I love your insight. Thanks so much for joining us again for this demonstration. Hey, last but certainly not least, let's bring in Tony. Tony, what do you have to say for us, man?
Hey, when we were first talking about this, I mean, I have to think in all my years of machining, I've never watched a comparison like a high-speed steel and then, a GOdrill and then a high-performance HPX drill where you kind of see it, bam, 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 and you get to see the chips flying off and just basically the performance benefits that come from stepping up. Drilled holes are sometimes something that's overlooked. There's not a lot of thought that goes into it. So we can see here, as I say, the proof is in the pudding. You've seen it firsthand from just a standard high-speed steel drill all the way up to the HPX drill. So time's money. That's what we work for. We work for money, and of course, time's money. So your return on your investment on these drills with reconditioning program and so forth is very, very quick. And then, of course, the increased capacity is going to allow to free the machine up to give you more parts you can run across it. So, the proof is in the pudding.
There we go. Whether you're trying to get the best tools in the industry, have yourself a beer on the beach, or optimize that machining process, the MSC and Kennametal team can help you do just that. And then last, got to give a huge thanks to my in-house CNC wizard over here, Aaron. Thank you so much. And honestly, as the machinist, do you have any general last final comments about all the awesome that we've seen today?
I mean, kind of just what Tony said, the proof is in the pudding. I'm going to talk about the Harvi real quick, because we've used kind of that original version of it. So bringing in the Harvi I TE, seeing what more we can do with that tool, it's just understanding that there's more out there. These machines are capable of doing more. Get the right tooling in your machines, create that capacity, and like Tony said, time's money.
There we go. From a machinist himself, man. Well, we appreciate all of our experts coming in from the Kennametal team. You are true industry leaders, and we are appreciative of you. Thank you, Aaron, for pushing all the buttons, because Lord knows if I did, I'd break everything. And it was really able to help us make an amazing demo. And we thank all of you for joining us. Make sure before you leave, give us a huge thumbs up, hit that like button. Also, head over to Kennametal and MSC's YouTube pages. Make sure you hit that subscribe button, ring that bell to turn on the notifications so we can keep you in the loop with all the amazing content that we're going to be releasing. And then also, for more information on MSC and Kennametal products, make sure you check out their website listed below. We've got the 1-800 number, should be in that description as well. Or you could always get that local expertise by contacting your local MSC rep. So hey, thank you viewers so much for joining us, for your questions, for taking time out of your day to come watch us make some chips. So this is Eddie, and thank you for joining us for Create New Capacity Without a New Machine, an MSC live event designed to deliver on our promise, built to make you better.